out. So let's review what we learned so far. Discrete random variable. And its probabilities. So let's start talking about a binomial experiment. An experiment is called a binomial experiment. Satisfies these important conditions. The very first one is the experiment has fixed number of times. Fixed numbers of times. Let us call it n. So we have n fixed as fixed number of times. Then we learn that these are all independent from each other. Independent. Okay, remember that the word that we associated with independent events was with replacement. With replacement, right? Okay. So we have an experiment that has fixed number of tries and they are all independent from each other. There are only two possible outcomes. Two possible outcomes. Success and a failure. Very well. So the probability of success is the same in each try. Probability of success is the same in each try. And finally, we learned that the random variable x counts the number of successes. Counts the number of successes. Remember that we said that, hey, x can be equal to 0. It means that we don't have any success. It can be equal to 1, just one success. It can be equal to 2, 2 successes, and so on. And it stops at n, because we have fixed number of tries, which is n. So the last value x can take is equal to n. It means that all of those are successes. Remember that we said that the probability of success is denoted by p, and the probability of failure is q, which is 1 minus p. Let us take a look at one example, everybody. Determine whether the experiment is binomial experiment or not. If it is, please specify the values of n, p, and q, and list the possible values of the random variable x. If not, please mention why. Example says, a certain surgical procedure has an 85% chance of success. A doctor performs the procedure on 8 patients. The random variable represents the number of successful surgeries. So let us run the poll. Is it a binomial experiment or not? Please take your time and answer to the poll. Make sure if your answer is yes, it's the binomial experiment. Specify your N, P, Q, and also what is X. If it's not a binomial experiment, you need to mention that why it is not a binomial experiment. Very good. So in this example, as you saw, N, or the fixed number of times, are exactly 8 surgeries. So N, in this example, we're checking each of these conditions, all right? N is equal to 8 surgeries. Okay, and from past studies, for example, the success is 85%. Okay, there are only 2 possible outcomes. Yes, your surgery is either successful or it's not successful. All right, you cannot say that it might be successful or not successful. A surgery is successful or not. So the second condition is also met. 2 possible outcomes. And the probability of success is the same in each try. Yes, P is equal to 85%. So you can quickly calculate the probability of failure, which is 1 minus 85%, or just 15%. Very good. And X, the random variable X, counts the number of successes, successful surgeries. So X can be equal to 0. It means that for those 8 patients, 8 surgeries, none of them are successful. No successful surgeries. Yeah, that may happen. Or just 1 successful surgery. Yep. Or 2 successful surgeries. 3 successful surgeries, 4, 5, 6, 7, and finally, all of those surgeries may be successful, right? So it's going to be 8. Remember that all those events are independent from each other. Well, surgery on one patient has nothing to do with surgery on the second patient, on the third patient, and so on. So those are all independent from each other. So in that case, in that example, we have a binomial experiment. Okay, let us share the result with you all. Well, so in this example, remember that we understood that we have a binomial experiment, right? As a statistician, you should be asking, well, how do I calculate the probability of, for example, x equals to 4? Okay, these are the questions that you should be asking. Question. How to calculate? To calculate the probability of having exactly 4 successful surgeries. These are legit questions. We said that, hey, we have a binomial experiment. In our example, we had a binomial experiment on 8 patients, 8 surgeries. And we checked that, hey, it is exactly satisfying the definition of a binomial experiment. But now we're posing some new questions, right? Okay, now that we have a binomial experiment, how do I find the probability of x be exactly 4? How do I calculate the probability? Question. How to calculate the probability of having less than 4 successful surgeries. These are legit questions. What is the probability of having more than 4 successful surgeries? These are the types of questions that we are interested in answering. So before talking about the calculator stuff, I'm going to give you the formula that is built into your calculator. We're just going to briefly talk about that formula, the probability formula for a random variable x, which is discrete and it satisfies a binomial experiment. But for the quiz, for the homework, for the exam, we're going to use our calculator. That's just for your information. So this is informational. If you haven't heard about factorial before, we're going to briefly talk about factorial. In math, we define factorial this way. We define factorial as, we say that, hey, 1 times 2 is defined as 2 factorial. This is expanded form, and this is short or compact form. So 1 times 2 times 3 is denoted by 3 factorial. 3 exclamation mark in front of it, then we call it, hey, factorial. 3 factorial, short version, expanded version. Well, we can continue this process. This is just the definition. 1 times 2 times 3 times 4 is denoted by 4 exclamation mark, or just in mathematical language, factorial. Continue this process. So 1 times 2 times 3 times 4 times n is denoted by n factorial. Well, what is 1 factorial? 1 factorial is 1. And for convention, they say that, hey, 0 factorial is also 1. So 0 factorial and 1 factorial are both 1. This is by convention. Okay, so why I define this? Why I say that, hey, we are having factorial? It happens that when you're talking about discrete random variables, specifically for binomial experiment, the probability of x is defined as using the factorial. So here you have n factorial divided by, on the denominator, you have n minus x factorial times x factorial. Then now you need to add your probability of success and the probability of failure. P to the x times q to n minus x. So this is the probability of x. As you can see, you have an ugly formula here, the probability of x, n factorial divided by n minus x factorial p to the x, q to n minus x. Guys, again, this is just for your information. Know these if you're in math, if you're in data science, and eventually if you're doing some research, you need to know these formulas. But in our class, we're going to use our calculator. All functions, the probability of x is built into your calculator. We're going to learn how to use our calculator to do the computations for examples like this.